Okay guys, this topic is called capture, recapture. Now I'm going to put this question here. If you want to pause the video now to try it, please do. And then you can check after if you're right. If you don't want to pause the video, just want to watch me, that's fine as well. Okay, I'm going to read it out first and then show you the working out that I do. The scientist wants to estimate the number of fish in a disused canal. He captures a sample of 30 fish from the canal. He marks each fish with a die and then puts them back into the canal. Now straight away, I'm going to say, right, so he's marked 30 fish with a die. So that would be here, 30 fish out of, now we have no idea how many fish are actually in this canal. So it's got to be leaving it as X. Okay, so 30 fish are marked with a die, but we've got no idea how many were actually in the canal to begin with. The next day, the scientist catches 20 fish from the canal. He finds that 4 of them are marked with a die. So 4 of the 20 fish he catches are marked with a die. Estimate the total number of fish in the canal. Well, literally all you've got here is equivalent fractions. If 4 out of 20 are marked with a die and 30 were died, we just say, well, how to get from 4 to 30? Times by 7.5. So therefore 20 times by 7.5. 20 times by 7.5 is 150, I believe. 20 times 7.5 is 150. Yep. So therefore this answer for X is going to be 150. So therefore we estimate there to be 150 fish in the canal. That's literally how it's based there, just based on equivalent fractions. Part B says write down any assumptions you made. Okay, so let's think of 2. So one assumption is that the population size stays the same over the course of a day. We have no idea. There might have been a few fish that have been born overnight. And the second one is it's completely random. So the randomness of the situation, that we picked 4 out of 20, as in we could have picked 5 out of 20, and then that would have affected what happened after. Okay, so therefore the population size not changing and the randomness of the situation. So same thing applies here, guys. If you want to try this one first by pausing it, you can, and then I'm going to go through the answer and see if you're right. So in order to determine snail populations, 340 snails were captured, tagged and released. So 340 out of however many snails, we have no idea. Later, 420 snails were captured. So 420 snails were captured. Of them, 16 were already marked. 16. What's the size of the snail population? So again, this is an estimate really, because we're working with equivalent fractions here. So equals, then I say, well, I know 340 were marked and 16 of them were marked when we picked 420. So 340 divided by 16 is 21.25. So therefore we're timesing by 21.25. So to work out how much the total is going to be, I times by 21.25 times by 420, and that would be 8925. 8925, and that's the size of the snail population in total. Okay, so have a go please at the forms quiz question now to see if you get it right, and if you do, you crack on. If don't, then I will help you live.